All right, kids, for the sample quiz number 4, I wanted to get this screencast for you so that you can study and hopefully get some clarity on these problems. Let me read it to you. It says, find the molarity of a solution made from 47.2 grams of sodium sulfate in 275 cubic centimeters of solution. So this molarity is a concentration. It's a way of us determining how much of a solute is in solution. In this case here, our solution size is 275 cubic centimeters, and we need to convert that, and we need to change that. But here's the 47.2 grams of our solute, and this needs to be changed to moles. So let's get started and see what we can do. So I've written down here the molarity, and we have 47.2 grams of sodium sulfate. So let's get started. So remember, molarity is the same as saying moles per decimeter cubed. So that should be a clue as to like what we're looking for, we're trying to get at. That's the goal. So let's start off with what we have. 47.2 grams of sodium sulfate. So what we need, and we're kind of looking ahead, is, here I'll show you what's going on. So 47.2 grams of Na2SO4. Sodium sulfate. So if I do this and I say, oh, I want to change it to moles, because I need moles, I know I'm going to put 1 mole here, and then in my denominator, I need a certain amount of grams. Grams of what? Sodium sulfate. And where would I find that? Well, I would find that on our periodic table. So I take a look and find the sodium and sulfate, or actually sodium, sulfur, and oxygen. 2 sodiums, 1 sulfur, and 4 oxygens. And when you do that, let's write it all out. I'll put it down here. Actually, let me put it on a new page so that we don't interrupt here. So let's get a new one going. All right. So starting up here, we have 2 sodiums. And each sodium is at 23.0 grams per mole each. All right. So then if there's 2 of them, that means we multiply 23 times 2. That gives us 46.0 grams per mole. All right, so that's just for the sodium. Sodium's done. Let's do the sulfur. There's 1 sulfur, and the sulfur should be 32.1 grams per mole. And then so 32 times 1 is 32.1 grams per mole. Okay, and then last but not least is oxygen, and there's 4 of them. 4 oxygens, and each one of those we said is 16.0 grams per mole. And that's going to give us a total of 64.0 grams per mole. All right, and what we do with that is we add them all up, and we get a grand total of 142.1 grams per mole. There we go. So just kind of double check and make sure you have everything. So we have here 23 times 2, 46. 32.1 times 1 is 32. 16 times 4, 64. And we add it all up, 142.1 grams per mole. Okay, so now that we have our mass, now we got to go back to our sheet and plug it in. It'd be 142.1. 142.1 grams. So I'm going to cancel the grams out, and those units are now canceled, and I have moles of this sodium sulfate still happening. Okay, the last step, because now look, I have this right here, I have moles, I need to get decimeters cubed. The only bit of information I have left is 275 cubic centimeters, and remember, 3 to the left means it's we'll convert it to decimeters cubed. We move our decimal to the left 3 spaces. So we're going to use decimeters cubed. So it'll be 1 over 0.275 decimeters cubed. There we go. And so now we're going to take our moles and divide it by our decimeters cubed, and we should get an answer of 1.21 molar. Let's see. So we take our 47.2. I'm going to divide it by 142.1, and then I'm going to divide it by 0.275, and I get 1.207856, and so forth. I'm going to round up to 1.21, and it should be moles per decimeter cubed, or 1.21 capital M molar sodium sulfate solution. Circle your answer, and there you have it. Hope that helps out. See you tomorrow in class, kids.